some chemical reactions to first of all determine if it's a redox process or not. And if it is a redox process, try to figure out what is actually being oxidized versus what in the reaction is being reduced. So I have my little ladder here. If you climb up the ladder, you are going through a Leo process. So I'm going to write Leo right here. And if you're going down the ladder, then you are going through a GER process. So here we go. First job to figure out if it's a redox reaction is to assign oxidation numbers. So here we go. In NaOH, it's a compound. So Na, group 1, it uses a +1. I see that there's hydrogen present. It's bonded to oxygen, a nonmetal, so it uses a +1. The oxygen needs to supply enough charge to cancel out the +2 supplied by the Na and OH, so the oxygen uses a -2. Next substance, the formula is a compound. I notice H. H is bonded to a nonmetal, so I assign it a +1. The Cl has to counterbalance or cancel it out, so it uses a -1. Moving on to NaCl. I notice Na is from group 1, so I assign it a +1. The Cl needs to supply enough charge to cancel it out, so it's a -1. I see the formula HOH. I have H's. Both are bonded to a nonmetal, so I assign them each a +1, and the O needs to supply enough charge to cancel them out, so a -2. So I have taken a look at this. I have assigned oxidation numbers. Now I need to do my analysis here. So I notice I start off with Na. It starts off with a +1, and on the product side, it still has a +1. So that means this is not redox. So it's not participating in redox. Okay, moving on to the next one. I see O. The oxygen starts off with a -2, and on the opposite side, on the product side, it still is a -2, so its oxidation number remained exactly the same. It's not participating in redox, so this is not redox either. Keep looking, there's more. So I see there's H. And both of the H's on the reactant side start off with a +1, and the H's on the product side are still +1s. And because the oxidation number has remained the same, this is not redox. And my last element present in the reaction is Cl. Cl starts off with a -1, and it ends with a -1. The oxidation state remained the same, so this is not redox. So not every chemical reaction is a redox reaction. So this is not a redox reaction. And I know this because there are no changes to the oxidations, to the oxidation numbers. So if it's not redox, there's no change in the oxidation numbers. That means there is, in this one, there is no electron transfer. So now if you take a look at this, in this reaction, the pattern is we have a compound plus a compound ends up forming two different compounds. When we see this pattern, we should recognize it as a double replacement reaction. Double replacement reactions are never redox.